So once you have a working pipeline and you have data loaded into the destination, you can take a closer look at it by using DLT pipeline, OpenAI admin, that's the name of our pipeline, and then show dashboard. This opens up a view that you can use for all of your pipelines. I have a lot of development pipelines here, but now I'm on OpenAI admin and I'm greeted with bright green telling me, okay, I was able to sync the status of the pipeline with the dashboard. You have a bit of information about where it's located, the name, the dataset name, and a bit some more global metadata. Then you can take a look at the schema browser and look at the different tables. For example, like show child tables, organization cost is related to organization cost results. You can take a look at the columns and show their ints. For example, DLT ID has to be unique. And you can add custom ints such as like identifying PII data. And I see that there's a duplicate here, organization projects with organization projects. The resource name is slightly different, probably due to when Cursor edited the code to load the data, but we can actually ask it about it. What is the table about? Is it different from table without the prefix, and when was each table loaded? We get the load table. This is where most of the metadata is. Markdown formatting breaks often with all of these underscores. This is from different. Both exist in your pipeline. The prefix, recent loads. This is it inferred about like the raw staging. It's not the case, I believe, but I can double check. Check specifically if the pipeline schema changed and if the tables are the same. Should be able to look at the metadata to see if the schema evolved, and it can look at the specific schema of the current table if they're matching. Okay, so they're identical. Okay, good enough. But that suggests that we can probably drop either one. Then you can browse the pipeline directly here. So you can, for example, pick the organization cost table, run the query, you can edit the SQL right here, and you can export it as CSV or another format for downstream use. That works for any DLT pipeline, so it's very convenient. Pipeline state allows you to keep track of the incremental cursor or other stateful information that you need. This is very useful for retries and debugging. Last trace is the deepest debugging tool. You see, it tells you when the last run was started and completed, the duration. You have some information about the compute system. So you see that I'm on Python 3.11 and I have 8 CPU cores. I think those are just like physical CPU cores, not virtual cores. And then you can drill down into the different steps. Each pipeline in DLT goes through extract, normalize, and load. And you can see that most of the time is spent on extract here. It's not surprising because we're waiting on API responses. And you can see the number of rows, you can see the size of the file that contains this data, and you can see where the checkpoint data is situated on disk. This is very useful, especially when the pipeline fails, because a pipeline can fail at extract, can fail at normalize, can fail at load. And let's say one of the API calls dropped or failed, I would be able to at least like investigate the responses that were successful before time on the retry. Pipeline loads is just a high-level view of the data that was loaded. So if I click here, so for instance, we see now that, okay, we loaded data into organization projects, but not the one prefixed with an underscore. And if we go to the other one, as I imagine, we have the opposite. So they're probably exactly the same. Okay, so that's it for the dashboard. Good. But if you're a data analyst, a data scientist, or ML expert, you probably want to use the data. The previous dashboard I showed you is mostly for engineers or platform teams that operate the pipelines. But for people interested in downstream use of the dataset, you can do DLT pipeline, OpenAI admin, the name of our pipeline, and then notebook. This is a templated Marimo notebook. It's the same tool as I was using before. Marimo is very cool. One of the main distinction it has with Jupyter or other notebooks is that it uses a graph to represent the relationship between the cells. So you never have notebooks that are executed out of order. Sounds simple, but if you work with notebooks enough, you know how painful it can be to not have this and have out of order execution. So the template just helped me get the pipeline, the dataset, and the connection to the dataset very efficiently. With the connection, it automatically populated this left side window that has a table explorer. And you can see the different tables. I know that these two are related, as we saw in the schema. And I can click on the plus icon to load this in a SQL cell. I will want to get some aggregates about the costs over time, and the dates are in this table. So I will select the DLT ID, which is the unique identifier of the row, and I will convert timestamp the start time. This is using the DuckDB SQL dialect. Actually, I don't even need the end time. Need the start time. And then, for example, I can use AI to help me and say, join this on table organization costs results on column DLT parent ID should match the DLT ID from this table. And then you press enter. Oh, okay, I'm not retrieving the columns, so I will look at OCR. Yeah, I will load those. Right, so we have all of the columns that we cared about. We have the DLT ID, start time, the amount value, and then the amount currency. So this is the column of main interest. And you can assign that to a variable. So you can say costs. I think I will need to execute it again, yes. And then from costs, you can access it in Python. So I think it defaults to pandas. You can do like start time and get the pandas series. But even better, let's use AI again. So you can reference it directly with the @ symbol and say, use the table costs to generate a alter line chart that shows weekly spendings. Takes a second, accept the data frame. So this is already a data frame. Can probably skip. It worked for 0 shot. And we have the other feature that tells us the spending per week. And we could tweak the visualization again, for example, like rotate the x-axis by 45 degrees. Now we have them angled. So when you do control period in Marimo, you're able to get a app view, and this is cool because it gives you a more streamlined display that doesn't include the code and that you can share with colleagues or with business stakeholders. You can export it to CSV again, which is very convenient. And this preserves the interactivity, and Marimo offers a large suite of UI components to make this very rich in terms of interactions. Even offers a grid view where you can have a 2D layout of your UI components. I think this is very cool. And DLT, since DLT is very lightweight, it can just run in the notebook, and it can easily refresh these applications. The last thing I want to show you is the new feature in DLT called, and a DLT transformation is something that takes in data that's stored on a data set, transforms it, and pushes back to the data set. So we have this data set that has raw data. And let's say we want to store these weekly aggregates directly inside DLT, the DB destination. I mean. How can we do this? We use AI, because why not? I will reuse this code directly. Actually, let's create SQL cell. This, run it in, and then say aggregate the amount value per week. You need to press enter. If this replace with actual. We'll need to. Let's try. Yeah, completion. Extract the week from start time and aggregate the amount value per week. Yeah, I don't think that's correct. We can add any value. Start time must appear in the. Let's just point. Okay, total. Okay, so this is like the number. We don't have a date, but we have the week number of the year. And we have. We don't want to group by DLT ID, and we don't want DLT. So yes, AI still requires you to read code. That's why we have a human in the loop. So we have a total amount per week, and this is not sorted. So I will just do it manually for order by week. Okay. So we have the same values that were displayed here, and this is just a SQL string, right? But inside DLT, you can write a transformation and call it weekly spendings or weekly cost. Take in a data set, and it will just directly place the SQL query there, and it will yield that query. So in the DLT transformations can do a lot of things. They can be written in Python, SQL. Let's keep it simple with just a SQL string in this case. And you can verify that it's correct by getting the weekly cost, right? Weekly cost. And then you give it the dataset. The dataset is the variable that we defined initially. So I'm getting a list because it's yielding the query, and I obtain a relation. So the relation is the description of the data that will be produced by this query. You can look at the schema. You have the DLT schema of what you expect. This matches the columns that we define. And you can, for example, get the data frame again from the relation. What's cool is that from the same data set, the same pipeline, I mean, that was called OpenAI admin, that pushes to the OpenAI admin dataset 2025, etc. And now run the weekly cost transformation. You give it the dataset and press run. And now see the weekly cost table is part of my data.